Hello and welcome to our latest webinar from Survey Tech. We've got a really good session for you today, talking all about structural analysis, how we can understand buildings, how we can use that data, and how we can monitor them afterwards. We've got a fantastic lineup of speakers who will be able to discuss all aspects of this. So it's Phil Jarrett from Geomax, Dave Schofield from Visualize, who'll be speaking about Move Solutions, and David Fernandez from Prosec/Screening Eagle. The format will be that there'll be 3 5 to 10 minute presentations, and then we'll have a Q&A afterwards. So if you have any questions that come to you during the presentation, there's a little box that you can type them into, and then at the end of the presentations, I will go through them and ask them to the speaker that you obviously want them directed to. It's really good if we can get that sort of interactivity and make use of our expert panel. So please do type them into the box. So with that said, the order of speaking is going to be David, then Phil, then David, and we'll start off just with a round of introductions in reverse order. So Dave, if you could maybe just tell us a little bit about how you came to be distributing motion sensors and movement sensors and the background to how you came to be here, and then we'll move on to Phil and then David can go straight into his presentation. So Dave, welcome to the webinar.
Thank you. Yeah, as Matt said, I work for Visualize. I started with Visualize in early 2020, but Visualize actually started distributing Move Solutions, I think in 2020, maybe 2021. So it's quite new to the UK market. It's only a few years old, and I'm there as the monitoring specialist, and to push the market forward in the UK.
Thanks, Dave. And Phil? Phil, you're muted. No. That's weird. I cannot hear you at all.
No?
Yes, now we can hear you. Although there's feedback.
Can you hear me now?
Yes, yeah, perfect.
Yeah, I don't know what's happened there. Right, so I'm Phil Jarrett. I work for SurveyMax. Look after all the Geomax dealers in the UK, so I provide them with all their support, information, and new product updates. So I'm here for the Geomax monitoring side of stuff.
Phil is one of the most helpful people in surveying. There's feedback. Phil, I think
yeah. So
no, I can hear myself back. Sorry, that's a bit of a technical issue. I think we'll let Phil try and sort out his sound and move on to David. Yeah, if you could introduce yourself and then maybe move into your presentation.
Okay, thanks so much, Matt, for this introduction. So I'm David Fernandez. I'm working in Spain in Screening Eagle Technologies. I am civil and structural engineer. So I've been working in the concrete and steel sector for the last 10 years. And then within the last 1 year and a half, I joined Prosec. And then I'm the product manager of the infrastructure sector.
Yeah, that's fantastic. So if we move into your presentation now, I'm just going to make you presenter. And you can tell us all about the smorgasbord of technology that Screening Eagle, Prosec. It's a bit odd there. Sometimes they're called Screening Eagle, sometimes Prosec, but Prosec, yeah, I think is a sort of a huge name in non-destructive testing, so they don't want to drop it. But the Screening Eagle is more broadly the company. Is that right?
Yeah, that's correct. And then I can start talking a little bit on the history. right? Because some people ask why we are called right now Screening Eagle instead of Prosec. You know, Prosec was a company that was founded in Switzerland, very close to Zurich, back in 1954. But then I think it was 5 years ago, because this company was involved
just put your presentation into there we go.
Okay, sorry about it. Now it's better for you. No? Okay, so I was saying Prosec was mostly involved in developing sensors, mostly. And then back in, I think it was 2018, 5 years ago, so they decided to join this company from Switzerland, from Singapore, which is called DreamLab, which is a software and robotic solution. And now this merge came to this new name, which is Screening Eagle Technologies. And now, as you see on the map, we have a lot of offices around the world, and also we are around 300 employees. But I don't want to focus on the company. I want to focus more on the solutions and the mission we try to bring. So this is our lemma: is protect the built world. And you know, this is very important because worldwide we have a lot of infrastructure. And then some of them, I wouldn't say most of them, but some of them may face these kind of problems within the years. You know, this is there are a lot of samples of structural collapse, such as those, and those are for the last 5 years. So this is very common, right? And this is bringing a huge social and economical impact, right? It's not only talking about how many people can die, it's also about the money you have to spend in reparation and in maintenance, right? So that's for us why it's so important to protect the built world. And for that, we bring an approach for this, what we call inspection ecosystem. So we have these on the left, we have these data capture sensors. Most of them, not all of them, but most of them are connected wirelessly to software, which is in an iPad tablet. And then all the data that you are collecting is going to go at the very end to a data platform with, we call it a workspace. So all your data will be safely stored on the cloud, right? And then on the other side, I'm not going to talk about this today, but we also have a software solution for visual inspections, which is called Inspect. And if you are interested, you can always go to our website. But I'm going to focus today on three, I would say the most three powerful sensors we have in our portfolio. Okay. So for the health of the concrete, whenever you are doing an inspection or maintenance, this is normally what the inspector do, right? They start with a visual inspection to see if there is some superficial defects. And then if they don't find any superficial defects, what you can try to find is if the rebar are correctly located, if the concrete cover is enough or is matching the requirements. Also, what about the diameter of the rebars? You may also want to know if there's some internal defects, such as void, delaminations, etc. For instance, if you want to check if there is corrosion inside, or if the compressive strength of the concrete is also good enough. So those are normally the technicalities, that you try to find inside the concrete. And this is not very easy to do unless you do coring, which is a destructive test, or the way we propose, which is non-destructive solutions, right? So today, I only have 10 minutes. I would like to talk about 3 different sensors, and those are 3 different technologies. Okay, so I mean, this is very summarized, but we have what we call eddy current, which is an electromagnetic field that is able to detect any kind of steel inside of the concrete. Then we have GPR solution. This ground penetration radar is a different technology. It's also able to detect any kind of different materials that you may find inside the concrete, not only rebars, but also plastic or air. And then for ultrasound, this is very good technology to detect air voids inside. So I'm just telling you that because in some cases, when you are doing inspection, it's very important to use not only one device, but 2 or 3 devices together. And this is because the technology is different, right? So for instance, the ground penetration radar is very, very good. I mean, this is, it's able to detect the energy reflected by the permittivity of the materials, right? So it's very good to detect metal or steel. It's not so good to detect air because the reflection from the wave is not so big. But then for the ultrasound pulse echo is the other way around, because we are, it depends on the acoustic impedance of the material. And in this case, you see that the steel is not completely reflected, but the air is really, I mean, almost 100% of the signal is reflected. So that's very important because in some cases you will see some examples later on. That's very important for the user to know that in some cases you need to combine 2 technologies together. It's not possible to find some issues with only one device. Okay, and then this is the first product I would like to talk about is GPR, ground penetration radar. And our system, we provide a variable frequency weight, which is very, very useful, right? Because whenever you use a high frequency, you are able to detect like smaller defects and more superficial defects because you have more resolution, right? But when you have a lower frequency, you can go deeper. But on the other way, I mean, you will find bigger defects. You won't be able to find smaller, very small defects. So this is very, very powerful because some competitors, they don't have this. So this is one of our unique selling proposition for this product. And this is a very good summarize of what we can find with this system. So you will find the first layer of rebars, the second layer of rebars, then PT dots. It's also possible to detect. But then on the other side, as I was saying before, if you have big delaminations in red or any other voids that are within outside this 80 centimeter range, you won't be able to detect it with this system, right? And then we have 3 sensors. So some of them are a little bit more powerful because they have a bigger antenna. Some others are like smaller, so you can go to smaller areas. But all of them are connected wirelessly using Wi-Fi to the software solution, right, that you can see on the right. And then, I mean, this is very, very, I mean, it's a small summarize, no, about what we can do with this sensor. But it is the software is really powerful, and we are updating the software like very regularly. So the first image you can see is the normal GPR signal you have in most of the competitors. So you will see these parabolas. So if you are an expert user, for you, it would be more or less easy to understand what is inside. But for not an expert user, we have this migrated view. So you can see the rebars in a cross section. And then you can always do also a plan view, which is very powerful because you can locate all the position of all rebars. And also you have this 3D view, which is also very, very, very amazing, I would say. So in this example, you see we have a PT dot in gray, and then you have these rebars, the first mass of the rebar layer. So you can see that one in blue. And then those are some examples of our users. So imagine you had to do some coring or some drilling. This is very powerful to detect where these rebars are located, and then you avoid the risk of hitting these rebars. Then that can cause a potential damage to the infrastructure. Then it's also very useful when you want to detect where any kind of steel reinforcement is inside. So it's also very useful for that. And as I said before, it's also possible to detect where or to locate where the PT dots are located inside. This is a sample of a bridge. So if you want to test where these PT dots are located inside the girder, this is also possible to do it. Okay. I'm sorry, I'm going very fast because I don't have a lot of time. Then for the ultrasound pulse echo, we have this other system. So in this case, remember I was telling you with ultrasound, you can detect very easily the defects because the air is reflecting the wave completely. And in some cases, you can also detect where the rebars are located. But this is a very powerful tool to detect internal voids, such as delaminations, honeycombs, cracks, etc. So, and also to detect the back wall. So it's also very useful if you want to check the thickness of the element. So this is what you would be able to see with this system. Then similarly to GPR solution, this is also wireless solution that is connected via Wi-Fi with the software. And then this is how it works in very fast. So we have 24 channels. So we have one emitter and one receiver. So the acoustic signal is traveling through the concrete. Then whenever it finds some air, in this case is the back wall, it will be reflected. So then this is how you will see it on the software side. So in this case, we are able to collect the back wall. I mean, in this sample. This is another example. Just let me go back. So you see here we have the back wall, and then there is a huge honeycomb inside. So this is for you to know the difference between GPR and ultrasound. So on the left side, you have the GPR. So you see it's very easy to detect the rebars, but it's not possible to detect the honeycomb, right? You don't see any bubble on the area where this honeycomb was located. But on the other side, on the right side, you have the ultrasound system, which is able to locate the rebars in the first layer, but it's not the most powerful tool to do it. But on the other side, you are able to locate the back wall and very easily to locate any big defects that is inside the concrete element. Okay. And here there is another sample. So you can see the GPR is really good also to detect the back wall. But whenever you have a delamination, as the air is not reflecting completely the signal, in some cases you cannot detect it. So for that, it's much more powerful to use this ultrasound pulse echo technology. And this is a really good example that a lot of users are doing. I think it's very, very helpful, is to detect whenever you are inspecting PT dots, if you want to detect if there's some internal voids inside because the grouting hasn't been done properly. And that's very, very, very important to know if there is corrosion or a likelihood of corrosion in this area. For that, this ultrasound pulse echo technology is very powerful, right? Because as I was saying, the air is reflecting the signal. All these areas you see in red means that this PT dot hasn't been fully grouted and there is some air inside. So this is very, very easy to detect if the grout has been properly done or not. And then finally, we have this other product, which is a covermeter PM1000. This is the technology behind is eddy current. So this is a very useful device if you want to know the concrete cover and also the rebar diameter estimation, which is very, very important whenever you want to do a renovation project. Of course, you need to do a new structural design. You always need to know the diameter and the spacing of the reinforcement, right? So for that, it's very useful device. And just again, it's wireless also. In this case, it's connected via Bluetooth to the app. And then this is, I mean, very summarize what you will get with this system. You can have a line scan, so you will see a 2D cross section of where those rebars are located, also with the concrete cover and the diameter on top of that. But you can also have this plan view or 2D view from top to bottom, and just to have a clearer view where those rebars are located, and also, as I was saying, the concrete cover estimation and also the rebar diameter. Okay, so just to finalize with that, I'd like to talk about this multi-technology approach, because depending what inspection you want to do, you will decide which device you prefer to use, of course. But if you use the three of them, you will be able to have the full image of this concrete element, right? You will be able to locate and to identify most of the problems or issues that you may have in this element. And this is just the last, I think it's the last slide. So this is a really good example we have with some colleagues some weeks ago. So it was a quality control for birth certificates of structural condition. So in this case, they decided to use these three sensors together. First of all, to locate where all the rebars were located, and just to contrast them with the as-built drawings, and just to state that this concrete element was complying, no, with the requirements. Then they measured in the middle of the picture, no, they measured the concrete cover. And in this example, they realized that there were lack of concrete cover in some areas. So you can see the red areas in red. I mean, in these areas in red. And then on the right side, you see they also decide to measure the thickness of this element. I think it was a retaining wall, or maybe a pilar, I don't remember. And then with the pundit, they were able to also to estimate this concrete thickness. So this is a good example, no, of some users using our devices. I think that's all from my side. Now you have some questions. You can just feel free to ask me anything.
Thanks, David. We'll come to the questions at the end.
Okay, that's perfect.
But that was a real rip-roaring move through some really great technology. So we've looked at the structure. We've potentially found some defects, and now we're worried about how it might move. So the next stage, I think, would be to look at monitoring for movement with a total station. So Phil, you've got a presentation on that. We can see your screen, but we can't hear you.
Can you hear me now? And is there feedback?
Yes. No feedback. Perfect.
Right. Okay. So I'll get through this pretty quickly, I hope. But basically, it's an introduction to the monitoring side from Geomax, which is a XPAD solution. So we have a standalone module called XPAD Automeasuring, which gives you options for single and automatic measuring within this module. Basically, the system is used to position the instrument correctly for every session of measurements, and from that measure the points that you're interested in for movement. So it's a quick system that then can export the data direct to offices, to the people who need to know the information. All that's required for this is a total station, controller, and the XPAD module for auto measuring. Obviously, if it's an automatic system, it's been set up for a long period of time. It's going to need external power to keep it going, whether it's a mains power or solar panel. We have all of these different options set up. So the way it would work is the total station can be connected to the tablet or controller via Bluetooth or a cable. You'd have external power going to both of those. And then for the structure that you're monitoring, you'd have your prisms set up. So in this case, we've got orange prisms set as our control points. They're in a static position that's not going to move, and they're not under the influence of the object that we're monitoring. In this instance, we're monitoring a bridge, and therefore the prisms, so our points of interest, are those red dots across the arc of the bridge. This is what's needed for this session of auto measuring to start. And like I said, it will work for a one-off where you turn up to site on a weekly basis, monthly basis, set up and use all the same positions. Or if it's a continuous project, every hour, every day, it can be left set up where it's a place where it's inaccessible, maybe a rail or a road job. The automatic measuring system would be the best option. So the way it works is for the automatic session, it's defined by an amount of time. So how often you want a session to be recorded. So how often you want it to set its position to the control, and measure all of the points of interest targets. After each of these sessions, depending on how you've defined your output, it will export measurement reports or warning reports direct via text message, email, straight into the cloud-based part of the system, or into an FTP server where you can then link it to a dashboard and have continuous updates in your dashboard. Obviously, that only updates every time a session's complete. And from that, then you can have warnings to your phone or emails, halt work on site, investigate what the issue may be. So if there's a building movement and people are on site, you can stop the site work before the investigation's done. The single session, so this one is started manually. So this would not be a system that's set up and left. This would be a system where you'd go to site with your equipment, you'd set up, it would measure its control with you manually starting that option, and then it would do its round sessions of measurement to your measurement points or your points of interest. After that, immediately on the tablet, it's displayed whether they've overpassed tolerances or whether they're within tolerances, and then it's upon the individual or the specifications or RAMs to what action's taken at that point. So the first thing it does is, for either of them, whenever you start a session, the instrument will measure the control points to reset to its position. Once it knows its position, it knows exactly where the points to measure or points of interest are, and then from that, then it starts to measure the points of interest. In all of the settings, you can predefine tolerances on what's acceptable, what's not acceptable. You can set how many measurements are done in each session. So whether it's 3 measurements per point, whether it's phase 1, phase 2, all of this is controlled in the settings before. And then once it's measured, the information is automatically sent straight out to your desired locations, whether it's an email, text message, or to a server. I've got a quick video of a session here, of a single session. I can run through quickly just so you can see the process. I think it's about 2 minutes, but it gives you a good idea of live what happens in the software as we go. So first of all, the station setup is done, and then you can add your control points. This is the very first time you go to site. You'd need to establish your control and the points that you measure to. So for this occasion, the control points are static prisms that are bolted to outside of the area of influence on the structure. Once the targets are established, it knows what it's looking for every time it does the rounds of checks. So if you've got some circular prisms, some 360, some retro targets, it will know exactly which one of these are in which location. So it knows what it's measuring to and the prism constants. You're always able to define the targets and change them at any given point in case any of them change. So we've now got control points. We've also just measured the reference points as well and established what prism type they are or measurement type they are. Then we can go into single measure and it'll give us our orientation of our instrument. We can start this automatically, and then it will automatically go around to the reference points, which are control, to get its station set up. And then from there, then it will measure its points on the structure. As soon as this is done, we can go straight to the report and check the tolerances on the points. So this here will show us the session. It will show us how far in and out of tolerance with the traffic light system, green or red, to show us if we're in tolerance or not. And then at that point, you're then able to share manually from a single session, but the automatic session would have sent that directly out to phones, emails, the person who needs to know the information. So that report can come out, so it can be points, individual points, so we can see all of the times an individual point's been measured and see how much it's changed, or it can be on an individual session to make sure no tolerances have changed in a single session, session being a round of all of the measurements. So the benefits of using this system, it's a fast setup, so once it's set up in automatic mode, it will just keep on measuring to your defined times. It's flexible, you can leave it on site or you can turn up as long as you've got your points measured, and it will always give you tolerances to them. Training with all of the XPAD stuff, we give training, there's online manuals, there's everything there, but once it's set up for the first time, there's never really any need to go back. The support can all be done remotely. So if it is on the side of a rail line or somewhere where you need possession to get in, what we can do is we can log in remotely to the tablets, change any settings we need to, or transfer any data, and check everything's okay from wherever you are in the world. And it's economically, it's a sound proposition for a job. The instrument's paid for, you don't need a person there all the time. Like I say, once it's set up, it's just the cost of the kit. And if you've already got the equipment as well, it's only a module upgrade to be able to do this. So if you've already got the kit and you want to start doing monitoring, it's an upgrade of a module, and then you're able to set these up yourselves and continue working. And that's the end of my presentation, if that's okay with you.
Yeah, thanks a lot, Phil. So we've started monitoring the building for movement, but now we're concerned also about vibration. So I think I know someone that might have a solution for that, a move solution, if you will.
Spot on. Right, let me go in here. Right, so I'm going to just introduce everyone to Move Solutions and who they are and what they can supply. So who are Move Solutions? They're an Italian-based company. They've got offices in Lucca and Milan in Italy, and they specialise in providing wireless monitoring sensors for both static and dynamic types of monitoring for structural health. They've also got their own web-based platform to remotely view your data, which is in real time as well. And I'm just going to take you through the different types of sensors, how the system works, and there's a bit of a case study at the end as well. So this is how the system works. So on the left-hand side, we've got our sensors and nodes, which we'll get onto in a later slide, and they connect to our gateway via LoRaWAN, which is long-range wide area network. And the gateway has a SIM card, or it can be connected via Wi-Fi if it's available on site via 3 and 4G. And all this data that the sensors send to the gateway arrives at the Move servers, where it's all unencrypted, put into a readable format, and it is pushed out onto the Move platform, or we can push out API or FTP if your customer's got their own platform for the data. I'm just going to go into the main sensors. So the first one is the tilt meter, which is classed as a static sensor, which just means it takes regular readings at time intervals. I think it's every 2, 5, 15 and 30 minutes. And can be used for things like static bridge deflection, can be used on rail for cant and twist, or can just be used on any sort of structure, a building or a wall, for any type of tilt movement. Moving on to the accelerometer, which is the next 3 sensors are actually classed as dynamic, which just means that they're always on. So the accelerometer is triaxial. As I just said, it's always on, it's always recording, but what we do is we set a threshold on the accelerometer, and then anything over that threshold you actually see the data for. It's just a way of ignoring all the white noise. Otherwise, you just get loads of data. And it's measuring the acceleration of vibration. So as soon as you get the initial shock of the vibration, it's measuring how quickly that comes to rest. It's also measuring the frequency of the vibration. So over a long period of time, should that frequency change, we're able to extrapolate data to see, or as a sort of an indication that something's going on with the structure. So that's more of a structural health vibration sensor, whereas the vibrometer is slightly similar. So instead of seeing an actual recording of some data, it's just plotting the peaks of the vibration. So it's PPV, peak to peak velocity. So it's millimeters per second. And it's just plotting on the graphs the peak of the vibrations rather than the accelerometer. It's giving you an actual, I think it's 12 or 30 seconds recording. Vibrometer is also triaxial. Moving on to the deck. So the deck is Moo's sort of flagship sensor, if you like. It's the first sensor that Moo produced, and it's a dynamic displacement sensor. So it's designed for bridge decks, but it can also be used in rail. It goes on to, say, the bridge deck, a load goes over the bridge, and it's measuring the actual displacement of where the sensor is installed. All these sensors, when they take a reading, they measure the temperature, the ambient temperature of where they are. A good thing with the deck as well, they all have sort of had their own tools within the platform that can help you easily understand the data that it's showing. Moving on to the nodes. So the analog node is a way of getting, say, geotechnical devices wired into the node. Things like wind, speed, direction, air, noise, strain gauges, load cells, whatever it should be, wired into the analog node, and then that pushes the data to the gateway wirelessly and then produces it on the platform. Cluster static, so I think it's just taking a reading every 2 minutes. A digital node is doing a similar thing by Modbus. It connects up to 30 devices, but again, it's just connecting digital devices to the node to push out onto the Move platform. We've got the new single channel node. So the analog node can connect up to 4 devices, whereas the single channel node is obviously just 1. But this also has the added accelerometer inside, so it can be activated by a trigger. So when something triggers the accelerometer inside, it actually takes a reading of the geotechnical device, whereas the analog and digital node is just every 2 minutes. Onto the gateways. So the SHM gateway, which is the older model, the Gateway Pro is actually the newest one. Gateway Pro, again, connecting to the sensors via LoRaWAN. You can get direct 12 volts now. It's powered over Ethernet as well. Easy access to the SIM card should you need one. And yeah, these are the devices that it's generally used on site to push the data onto the platform. Moving on to the actual Move platform. I'm not going to delve too deeply into it because there's actually a new version of the platform being released in a few months. So instead of going through all the different tools, we can go perhaps do another webinar further down the line, and I can delve deeply into the tools and how the data is readable. But this is where we use the platform to actually read the data and easily extrapolate what we want to see. So initially, whenever you log onto the platform, you'll see the dashboard. That's always your home screen. The picture that you can see on this image is completely customizable. Take a picture of the structure and place the sensors where they actually are installed on the structure, so you can easily then see if an alarm goes off or a threshold is alerted. You can see actually which sensor it is on the structure. And the dashboard is the last 24 hours. So it's just like a quick snapshot of what's happening on site. Then we can get into the actual raw data. So you can go to the menu and go to events, and that's when you can select an actual the date range. So you can do the last 6, 3, 12 months and see the historical data of what's happening with that sensor. And like I say, we do provide tools within the platform that have algorithms that are built to help you understand the data. Things like static deflection for bridges, you set up a row of tilts, you have your load go over, and then every 2 minutes it will take a reading of the deflection of the tilts. Displacement detector, so a scatter graph of displacement, model frequency, which is what we use the accelerometer for. So these are more of a long-term monitoring. So as the structure changes over time, you're able to see how it's being affected. We've got a new rail tool, so we can measure cant and twist and vertical deflection. That's with the tilts. It may well be tilt beams as well on the rail. This is a general sort of how things might be installed on site. So this is a picture of just a construction site. So the green dots on the far building, that's where we may install or we may have vibrometers to see if there's any vibrations coming from the construction site, if it's having an effect on the surrounding structures. And then on site, depicted in red, is your actual tilts, measuring the piles, which again can be installed on tilt beams or just singly. So that's sort of a quick install. And on to a case study. I do need to thank Emmanuel Durand from Amman Engineering for letting us use this case study. So you might remember August 2020, there's a huge explosion in Beirut that's completely destroyed the other side of these silos. As I Move Solutions sensors, tilt meters were installed on the silos to sort of measure if and when they may collapse. And I believe it was in July 2022 they eventually collapsed. But Amen Engineering were set up for the engineering or the monitoring using tilt meters. And this is some of the data that was shown. So this is the last month of July. We see sort of regular readings during the day, during the night, of it being, steady movement, regular movement. And then around the 20th of July, we start seeing irregular movement going in one direction and then another. So I believe the site was evacuated. And then I think it's 10 days later, they actually collapsed. So thankfully for the monitoring of the move tilts, so lives were saved and no one was on site to get hurt. And I believe that's it. That's me to an end. I think we've hopefully got some questions from Matt.
Yeah, thanks a lot, Dave. That's great. And a really good example of how all of these technologies actually can improve safety in the construction industry. So the first question that popped into my box while David was speaking was you mentioned a birth certificate. Should we also have an MOT for structure? I probably have to translate that for you because you're in Malaga. Yeah. An MOT is something that you get annually with a car to check it's roadworthy. Should some of these big structures be inspected annually for defects and things, and is that something that should be developed as an industry, in your opinion?
Yeah, I think that depends a lot on the infrastructure and in the country, right? Because you have some standards that require to have, let's say, every 1 year or every 2 years, these kind of inspections. For instance, in Spain, for the railway high-speed trains, you had to inspect the bridges every 2 years. So for that is, of course, these NDT solutions are very good, right? And they are used. You first do these visual inspections. This is what you normally do first, and then you go to NDT solutions. You want to go more in deep.
There was also a question about whether your sensors could be combined. I mean, if there's some sort of, I don't know, eddy current and GPR in one, maybe that's in the future.
Yeah, that's a very common question, and that's why I was talking about technology, right? It's complicated to combine the two sensors in just one sensor because we are talking about different technologies, right? Of course, it would be possible, but it would be a much bigger sensor, and then, of course, a much more expensive, right? And that's not good for some clients because some clients, they just want to buy one of the sensors, so for them it's more economical in this way. But we know some users, what they do is they attach the two sensors together with an accessory, and they just do one scan. They use two sensors, but they just need to do one scan in one go. So that's also another possibility.
And then the next question was, could all of these technologies be used with digital twins? And I think to be honest, I think the answer is yes.
Yeah.
I know, David, the Inspect software is a kind of a digital twin platform.
That is, yeah.
If you could briefly just give a quick description
of
that.
So, yeah, I was talking about sensors, but if you remember at the very beginning of the presentation, I was talking all the data is pushed to the cloud, to Workspace, which is our data storage on the cloud. And then we have Inspect, which is a software solution. So then, I mean, just generally talking, this is a software for visual and sensor monitoring inspection. So you can create a new asset or a new, let's say this is a bridge. So you can create a 3D digital twin, let's say, and then you can create, imagine you are doing an inspection on a girder or in a beam, you can create what we call a spot. So then you create a new spot, and then you can attach any information from any sensor automatically, right? So imagine you are doing a GPR inspection in one girder, then you can, let's say, export and import this information from the GPR sensor into this platform, which is called Inspect. So yes, all our information is connected to a digital twin if you have this software.
And I mean, one of the things that links all these technologies is that, of course, you can get them from Survey Tech, but also it's that using them in combination can often be very productive. So Phil, I think you discussed how the output can be sent to the cloud automatically from movement monitoring. I wonder if that's something that can kind of be incorporated into a digital twin, if that's been set up like that.
Yeah, if you're running a lifetime project, then the information, depends how long you have the system set up for, how often you have to go back and investigate. But all of the data can go back to a similar place. I'm sure both the other platforms go to FTP, so their own customer servers, they can port the data there. And I'm pretty sure there'll be lots of, I mean, pretty much the data can come out in many different ways. So it can be a CSV file, it can be lots of different formats, and it will go into nearly all softwares, depending whether you want it to be displayed in a dashboard type system or whether you just want it as records. It could all go back. But the good thing about using it with the total station is you know where everything's positioned. So for Dave's Move Solution sensors, you can make sure you know exactly the locations of those on the building with the instrument that you're using, as well if you're monitoring prisms at the same time. And for David's GPR scans or eddy scans, any data that's collected, if he's doing it on a grid, you can position the grid with the total station as well. And therefore you've got accurate information in actual position, not just information of how far the rebar are back. You'll have all that as a picture, but then you can actually place it into a digital twin model in the right location. And same with Dave's sensors. If you know the left wing of a building's moving on his sensors, you know exactly the position of that part of the building in a 3D space.
Mm. And Dave, from your platform, obviously you can put the sensors into a picture, but I think we did actually discuss maybe a workflow using SimLab for Matterport, where you could get the output in a full digital twin, so you could walk around the space and see exactly where they are. I think that would be the next step, right?
Yeah, I think you can. There's already, I think, a couple of customers that are once they've gone out to their asset or the structure and done a scan, they're georeferencing the sensors that are on a building or structure, and that can display it in the actual software itself. So things like Cyclone or Bentley or SEC or Matterport. We can FTP the data straight to their platform, or we can create hyperlinks within the digital scan or digital twin, which then displays it on their actual platform, or hyperlink it to the Move platform. So either way, we can put it on theirs, or we can send them directly to the Move one.
Mm. So we're kind of moving to a much more spatially based storage rather than sort of simple, databases where you can actually see the sensor and where it is and what information we have about it, and potentially the scans, because delamination or corrosion or something being in that area would really inform what we know about that movement and things like that. So I think it's a great sort of overarching idea of how the different technologies work together. There's just a little question for you, Dave. It says the Gateway Pro has built-in GPS. Why?
To know its location. You can on the platform also set coordinates of where the project is, and you can get that from the gateway. But yeah, it's just a built-in ready.
So kind of in your back end, you'll be able to see where all the projects are based on the GPS gateways.
Yeah, and that can be put into the actual. So I think if you didn't want it in the image on the dashboard, you can use things like Google Earth or Google Maps, and it takes the GPS from the gateway and displays that on the dashboard.
Yeah, and of course all the sort of the widely available tools on things like Google Earth, they're just getting better and better. So in terms of supplying the digital twin, who knows, Google might actually be what you're putting the data into.
Yeah, I think
knowing what they're like.
We're in Italy last week, and Move, that's something Move are already looking at in the new release of the platform, is building instead of a static image, a model that you can actually move around within their own platform. So that is in development.
Oh, that's great. And the last question really is where do we see this technology going? Is it sort of greater integration? And that's basically a question for everyone. So should we start with you, Dave? Where do you see the technology going?
So this is ideal for Move to get these sensors out on all built, environments to monitor, smart cities, new cities that are being built, to monitor them. It's something to get out there for structural health, not just being reactive to, there's potentially something wrong with that structure or that one, is to get it rolled out of everywhere so we don't have a bridge collapse somewhere. Is to have everything monitored so we can see the health and be proactive and put things in place
And
before
presumably the more
something actually
data,
happens.
the more data we get from your sensors, the better we'll be able to understand if when there are issues, what that looks like.
Exactly.
Yeah, that's interesting. And Phil?
Yeah, like Dave said, it's got to be proactive to foresee the incidents that may happen. Like I say, it's all for safety, but in the long run, the investment that's made in this monitoring is going to outweigh the problems when something does go wrong. With it all as well, population's at an all-time high and it keeps growing, so therefore buildings are going up rather than spreading out. The higher the buildings, the bigger the infrastructure, the more cars, bigger the bridges, everything then is more dangerous, and there's a lot more material and a lot more stuff to check with the footfall and amount of people that are using all of the infrastructure that we have. It's good that a lot of the manufacturers now, I think there was a case where everybody was siloing everything into their own softwares and trying to keep everything in-house, but now the data exports from everything can pretty much go into lots of different unique platforms that serve businesses well. Business shouldn't have to have 20, 30 different softwares just to see individual bits of data, but being able to take the data from sensors and bring them all into one location is really what will benefit any company doing this lifetime care of infrastructure.
Yeah, I think that's a really good point. You know, shareability and not siloing it. I think, you know, as an industry, we need manufacturers need to make sure that they realize that, because it's all well and good saying wanting to sell more of your own products, but if you do it at the expense of democratizing the technology, that's not a good way to go. And David, what are your thoughts on the future of the technology?
Okay, so yes, I have a strong point here. You know, the build world is getting bigger and bigger every year, right? And now I would say the owners are just getting cautious that the inspections and maintenance is really important if you want to extend the life of the infrastructure. And I would say non-destructive technologies, they're getting more popular these years, right? Because we are also democratizing it, so it's easier for the users, right, to use it. And we are talking about technologies that are quite old, GPR or eddy current. This is an old technology. What is different right now is that software capabilities are, they're growing exponentially, right? So it's much faster to collect data right now, and also, I mean, with the computer or with the iPad, it's much more powerful today. So I think it's gonna grow exponentially in the next years.
Yeah, I think it's well said. You know, that sometimes the technology gets to a certain point, but it really requires good user-friendly software to interpret that data. Yeah, I mean, and GPR is an extremely good example of that. You know, the difference in visualization from 10 years ago, where you'd sort of be staring at a few squiggles on a screen, to like a full augmented reality slice through a building is it's extremely the visualization is streets ahead. But yeah, okay, well that's the full hour, guys. Thank you so much for all your presentations and your insight into the built world. These webinars are generally recorded, so we'll be putting that up as a resource afterwards, and you can watch previous ones on our YouTube page. But for now, I'd like to thank my speakers, Phil Jarrett, Dave Schofield, and David Fernandez-Ero. And I'd like to thank everyone for watching, and have a great day. Bye-bye.
Cheers.
Thank you.
Cheers, Matt.
Bye-bye.
Cheers.